today's tutorial, we're going to be adding geometry waves to our water. Currently we have ripples, but these are very small, and if you look at the edges of the water where it intersects with other objects, you can see that the water plane itself isn't moving at all. So today we're going to fix that. We're going to add animation to the water surface. Before that, there are a couple of things that I want to do to add a little bit of polish to what we did last week. Let's switch over to our shader and we'll take a look. So the first thing that we want to do is clean it up a little bit. Last week we removed our rain ripples just because we have a nice clear sky environment. And so what I want to do is just go ahead and delete these nodes that are creating the rain ripples to clean up our shader graph and to get these things out of the way, just to make it a little bit nicer. The next thing that I want to do is, if we take a look at our water, you can see that it has this really odd looking green color stripe on it. And especially if we look over here where it intersects the wall, it has this really strange looking stripe. So I want to fix that. And that's being caused by the depth fade node that we're using right here. So we're using depth fade to kind of fade out our water on the edges, but we're also using it to determine what color to blend to. And what I want to do instead is only use this depth fade for our opacity, but I want to skip it to determine what color to use. So let's go ahead and save the shader. And we'll jump over here to our environment. And now you can see that really weird light blue stripe is gone. Now there is one more thing that I want to do to add polish before we jump into our geometry waves. And that is, you can see that there's a lot of deformation happening here, and it kind of causes this hard line on the edge of where the water is. And so what I want to do is tone down the refraction at the edges where the water intersects other objects. And the way that we're going to do that is with this depth fade node. So here we have the amount of refraction that's being applied. And I'm just going to add a linear interpolate node. And what we're going to do is we're going to blend between the amount of refraction based on this depth fade. So I'm going to wire my depth fade down here. So when depth fade is full, we're going to have the full amount of refraction. But when depth fade is black, we're going to just have 1 for refraction, which basically means none. So I'll wire this into the refraction node. So now you can see I'm blending between 1 and 1.33 for my refraction based on how much depth fade is happening. So I'll go ahead and save that, and we'll take a look at what that looks like in the scene. All right, so now you can see that that refraction that we used to have on the edges is toned down quite a bit, and our edges fall off really nicely. So with that little bit of polish out of the way, we're ready to jump right into animating the surface of our water. The first thing that I want to show you is that we're going to have a problem when we start trying to animate the surface. To show you that, I'm going to switch over here to wireframe, and what I want you to see is this plane that we're using is very sparsely tessellated, or in other words, there aren't that many triangles. So if we start trying to move the vertices around, we're going to have this very coarse animation. So that's the first thing that we need to fix. So I'm going to switch over here to my shader, and we're going to come down here to tessellation. And what the word tessellation means is basically splitting up the triangles to make more of them. So I'm going to turn tessellation on, and I'm going to pick flat tessellation. And what this is going to do is it's going to chop up my triangles and just make a whole bunch of triangles for me. So I'm going to save that, and then we'll switch over and see what that does to our plane. Alright, so now if we switch to wireframe again and select our plane, you can see that now we have a lot of triangles. It's not just a few triangles like it was before, but there's like a ton. And so this is what we need actually to be able to animate the vertices. Now I will say that tessellating the triangles like this it makes the water surface a bit more expensive because it's having to draw so many more vertices. And so one thing that we need to do to control the expense is this value over here called the Tessellation Multiplier. We need to control this value really carefully so that our triangles, or so that we're not drawing too many triangles. Now, if I were to do this the right way, I would measure the distance between the camera and my surface, and based on that distance, I would reduce the tessellation multiplier. So the further away the camera gets, the fewer triangles there are. That's a little bit complicated and a little bit outside the scope of what we're trying to do today. So instead, what I'm going to do instead is just add a constant, and I'm just going to give it like a constant of 0.5, and I can control, or I can change this value lower if I want fewer triangles and higher if I want more triangles. All right. The next thing that we need to do is start working on our geometry deformation. And in order to do that, usually you would use world position offset, but because we've used tessellation, we're going to use world displacement instead. And that means we're going to create a mathematical formula that will move the verts of our geometry up and down using world displacement. We're going to use a mathematical formula that simulates ocean waves, or that's good at imitating the behavior of waves. And the formula is called the Gerstner formula, or Gerstner Waves. I'm not going to go into a really big explanation of how this formula works. It's a formula that you can find in a lot of places online. What I'm going to do is just create it, and then we'll take a look at the results. So first I'm going to move my graph down just so that we can have plenty of space to work up here in the top portion of our graph. We need several controls to control our waves. So I'm just going to add a bunch of constants. The first constant that I'm going to add is the wavelength. And just for starters, I'm going to use a wavelength of 450. Now, Unreal uses units in centimeters, so this is like 4.5 meters of wavelength, which means that's the amount of space in between each of the waves. And now I need the constant of pi. So I'm going to put that down, and the value of pi that we want is actually 2 pi, so I need to make another constant and give it a value of 2. So we want to do 2 pi divided by our wavelength, and then we want to multiply this value by the gravitational constant. And the gravitational constant on Earth is 9.8 meters per second. Now, you could be creating water on a different planet with a different amount of gravity, but generally all water on Earth is going to have this constant of 9.8 meters per second. And again, because we're dealing with centimeters instead of meters, we need to use a value of 980. Now, after multiplying by the gravitational constant, we need to take the square root of that value. And then we need to multiply this by time. And this is going to provide the animation that we're looking for. So I'm going to create a time node. All right, so this is going to control the speed of our waves. Now, the other thing that we need is position and direction. So I'm going to bring in the world space position of our vertices. And here's a really important setting. If we come up here under world space position and we take a look at the setting, it says absolute world position, including material offsets. Now, what this means is it's the world position after the vertices have been moved. And we can't actually move that, or we can't actually use that, because this is part of the shader that's going to be moving the vertices. And so instead we need to pick excluding material shader offsets. So this is going to give us the position of the vertices before they've been moved. We also need a constant for the wave direction, which will give us, which direction is the wave flowing in. So I'm going to make a new constant, but this is a vector 3. And we're just going to give it a default value of x, so it's moving in the x direction. And this value needs to be normalized. Eventually it's going to be a value that we can input, and so we need to normalize the input that we get. And then we need to multiply this by this 2 pi divided by our wavelength. And then once we have that, we need to do the dot product with the world position. All right, now we can subtract our time value. And then feed that into a cosine. And this is what's going to give us the waving movement. And the interesting thing about sines and cosines in Unreal Engine is they have this period value. So if you see a sine or a cosine in a math formula online, you need to give it a correct period value here. And the default period value for Unreal is 1, but in a math formula, the default period value is actually 2 pi. So I'm going to give it this value of 6.283185, which is 2 pi, so that this cosine will act like a cosine function in a math formula. And now we're going to multiply it by a vector. And what this value is doing is I'm going to multiply it by a constant 3 vector. And the purpose of this value is to adjust everything except for the z, which is the up and down. We only want our verts to be moving up and down. All right, and then we have one more constant to multiply by, and that is the amplitude or the wave height. So I'm going to add one more constant, and this is our wave height. And for now, we're just going to use a height of 2, which is 2 centimeters. This is going to be kind of a really subtle wave for now. And with this formula in place, we can now connect it to our displacement. So I'm going to go ahead and move this down just a little bit, maybe down to like right here. And then I'm going to wire this into my world displacement socket. And I'm going to save that, and we'll take a look at what we get in the scene. All right, so you can see that I've got my water animating just a little bit. Let's zoom down here and take a look at what it looks like. It's really subtle, but you can see that we've got our water moving up and down. And this is pretty cool. It adds a lot of realism to have our water moving. And I really like what this has done to help the water feel even more like water than it did before. There are a couple of things missing, however. The first thing that's missing is part of the Gerstner math formula is steepness control, and we haven't added that in yet. So right now our waves are perfectly smooth, but one of the things that the Gerstner formula gives us is the ability to control how sharp the crests of our waves are, or how steep the waves are. So let's go ahead and put that into our formula. So the first thing I need to do is kind of move these nodes up a bit to give us just a little bit more space. Just going to clean up my graph here just a little bit, make things a little bit more compact, and then we will create our steepness control. All right, so the first thing that we need again is another constant, and this is going to control the steepness. This is a value between 0 and 1. And just so that you can see what's happening, I'm going to give it a value of 1 so that it can be like maximally steep. All right, and now we can take our wave height value. I'm just going to move it down here, and we're going to multiply our wave height by this 2 pi divided by our wavelength. So I'm going to add a new multiply and multiply that by our wave height. Then we're going to take our steepness value and divide that by our amplitude or our wave height multiply here. Then we're going to multiply that value again by our wave height. And then finally, we're going to multiply the result of this by a sine value. So I need to add a new node up here that gives us the sine of our position values here. And just like I did with cosine, I need to copy this 2 pi value and put it in the period of sine. So now we're going to take that sine value and multiply it with our result down here. Alright, and then I need to take our direction and multiply that in. And that gives us our steepness value, and we need to subtract the steepness from the offset value that we already calculated. So now, instead of wiring this result into our displacement, I'm going to wire this result in, and we'll save it and take a look. Okay, so now if you take a look, we can see that as our wave goes by, there's a little bit more of a sharp point to it. And I'm going to adjust our values just a little bit so that this is a little bit more obvious. So the first thing that I'm going to do is adjust our wave height. Let's set this to 6. We'll come back and make it subtle in just a minute, but right now I just want to kind of show you what this is actually doing. And I'm going to reduce our wavelength to, I don't know, maybe 200. Alright, so now you can see that instead of the waves being nice and soft and smooth, we have these really cool looking peaks. And that's one of the advantages of the Gerstner formula, is that you can control like how choppy your water is. So that's a pretty neat characteristic. Now, this doesn't really look like water. There are a couple of things missing. The first thing that's missing is we are changing the shape of the surface, but we're not actually changing the direction that the surface normal is facing. So that kind of gives this really strange optical illusion, like our surface is still perfectly flat, but it's not. It's shaped like waves, but the way that it's being lit and the way that the reflections are working, for those purposes, our surface is still flat, and that's completely incorrect. And so we need a way in our math formula of recalculating the surface normal so that it's no longer flat. So let's jump back to our shader and go ahead and calculate a new surface normal. I'm going to do that math up here. So we need to take this multiply value and multiply it by both sine and cosine. So I'm going to go ahead and add a multiply and duplicate it. And we're going to multiply the first one by sine and the second one by cosine. I'm going to go ahead and wire in this multiply value here. And then for our sine value up here, we need to multiply this by our direction. So I'm going to add another multiply and then grab my normalized direction. And then this is going to be the x and y value of our normal, so I need to mask it out. Add a component mask, and I'm just using the R and G, or the x and y components. And now for my cosine value here, I need to multiply this by the result of this divide here. Alright, and then I need to invert this, so I'm going to add a 1 minus node. And then this will become my z component of my normal. So I'm going to add an append vector. And my x and my y are coming from my sine, and my z value is coming from my cosine. Now this will give me the normal that I'm looking for, and what do I do with it? Well, if we come down here to our shader again, you can see we have this set of nodes that's creating the ripples on the surface. And what we need to do is combine our wave normal with our ripple normal. So I'm going to add a new node in here. called Blend Angle Correct Normals. And this is going to allow me to combine my ripple normals, which I'm going to call the additional normal, and my normal that I'm generating from my waves up here, which I'm going to call my base normal. So I'll connect that up and then wire that into my normal output here. I'm just going to scoot things over just a little bit. And I'll save that and let's see what we get. Alright, now you can see that we've got some really nice normals being generated by the waves, and they're combining with the normals for the ripples, and we're getting the correct result of both the normals and the waves, ripple normals and wave normals combined together, and it looks really cool. It's a little bit severe, however, because we left our steepness value at 1, so these waves have these really sharp peaks, and that's a little bit too much. So let's switch back to our shader again, and let's tone it down a little bit. So I think for the wave height or the amplitude, we're going to set that back to 2, and we'll set our wavelength back to 450, and we're going to set our wave steepness to something a little more reasonable, like 0.3, and we'll save that. And now you can see we have these really nice, soft, slower moving waves, and we get this really nice ebb and flow movement. I really like what this is doing. Now, we could just stop here, but in reality, all we've added is a single wave that's going over and over the same speed. And in reality, waves actually go in lots of different directions at lots of different speeds, and so we need to take this just a little bit further. You can stop watching at this point if you want, but we are going to add one more really cool feature. What I need to do is take all of these nodes that I've created here to create our waves, and I need to turn them into a function, and then I need to call that function a couple of times and give it different parameters. So that's what I'm going to do. I'm not going to make you sit here and watch while I make a function. I'm just going to do that, but then I'll come back and show you what I did, and then we'll be able to use the function multiple times to create waves that are flowing in different directions. The combination of these waves will give us a much more realistic look than what we've got now. Alright, now you can see that I've created a new shader function, and I've taken all those nodes that I just created that were doing the vertex offset for me, and I pasted it into this function. Now, instead of those green nodes that I was using for constants, I'm actually using these input nodes now too. So this is my input direction, and I've defaulted it to X. This is my input for wavelength, and I've defaulted it to 450 like we had in our value before. This is my default for height or amplitude, and I've defaulted it to 2, just like we had before. And I didn't expose my gravitational constant, my 9.8 meters per second. If I knew I was going to create water that needed to look correct on lots of different planets, I might expose this value, but in this case, I'm just going to be using earthly water, so I left that as a hard-coded constant. And then finally, we have this wave steepness value. And then my outputs are my offset for my vertices and also my normal. So what I can do now is take this material function and add it to the material that I was working on. So here are all the nodes that I created previously. And here's that function. This function contains all of this. So what I can do now is get rid of all of this and just take my function and wire it in instead. So I'm going to grab my normal and connect it up right here. And I'm going to grab my offset and connect it up right here where it says World Displacement. And now I can just grab all of these other nodes that I'd created previously and delete them, because all of this functionality is contained right in this little package. Now, the really nice thing about having our waves in a function like this is that we can create multiple waves. So I can just copy this wave node and paste it, and just like that, we've got 3 waves. And I can take our offset values and just add them together. And I'll need to create nodes here to combine the normals too. Now, there is one problem, and that is each of these waves is just using the default settings, so they're all going to be the same direction, the same height, the same length. And so what I need to do is create parameters here so that each wave has its own unique set of settings. And boom, through the magic of editing, I've now got different settings for each wave. So you can see here, my top wave has the wavelength of 450 that I had before, but now I've got one with a wavelength of 490 and one with a wavelength of 530. They've also each got their own unique direction, height, and steepness values. And you can see here how I've created the normal blends using blend angle correct normals. So I'm blending this normal with this one, and then I'm blending the result of that with the normal from this one. And here I've got my offsets added together. Now I can just take my offsets and put them right in here to my displacement, and I can take my normals and combine them up right there with my blend angle corrected normals again. And I've got my final shader. So now I've got 3 different waves going in different directions with their own unique height and length and steepness settings. And so let's save that and take a look at what we get. And so now you can see that we've got waves that look quite a bit more chaotic. The goal of combining the 3 waves together is to break up that really repetitive pattern. And if we take a look here, you can see that my water undulates around and up and down in a little bit less repeating of a pattern. And this is exactly what we're looking for. A lot of what we do in creating shaders is trying to get rid of those tiling patterns or repetitive patterns. And so that's what we've done here. We've got 3 different waves going in different directions with different settings, and it just makes something that is a lot less predictable and repetitive. So going back here to our shader, one thing that I did want to point out is we have lots of different settings here, and none of these are really set in stone. You can customize these however you want. If you have really rough seas, you could create really big waves with a lot of steepness value. Or if you have something really shallow and calm like I have, you can kind of tone these values down. But there's a lot of latitude for control here to get the effect that you're looking for. Well, I hope you've enjoyed today's tutorial on adding Gerstner waves to our water shader. If you did, be sure to subscribe to the channel. For next week's tutorial, I was planning to add foam to the surface of the water. Let me know in the comments if that's what you'd like to learn about next, or if there's another topic that's more important to you. Thanks for watching, everybody, and I'll see you next week.